If we regularly observe the night sky over long periods of time, we will notice that the stars and the patterns they make, called constellations, appear in the same regions of the sky at the same times each year. In contrast, the locations of the planets change. That is because planets appear to wander among the stars. In fact, our word planet comes from a Greek word meaning wandering star. Many ancient civilizations tried to predict where a planet would appear among the stars on a particular date in the future. The most successful ancient mathematical scheme in forecasting planet positions was put in its final form by the Greek astronomer Claudius Ptolemy, who lived in Alexandria, Egypt in the 2nd century AD. Calculations using Ptolemy's scheme, which had the sun, moon, and planets in motion around a stationary Earth, produced reasonably accurate positions, but at times the predicted positions were off by several degrees. In 1543, Nicholas Copernicus published an alternative model with the sun stationary and Earth as one of the planets. But predictions using his model also gave inaccurate positions at times. A young Danish nobleman named Tycho Brahe noticed this problem and decided to do something about it. He reasoned that to construct a better model, many accurate observations of planet positions were needed. He designed and built instruments that he used to make the most accurate astronomical observations that had ever been made to that time. After Tycho's death, Johannes Kepler, one of Tycho's assistants and a gifted mathematician, took charge of Brahe's more than 20 years of observations. Kepler battled with Tycho's observations for years before he finally discovered how planets actually move around the sun. While his new astronomy was not easily accepted by many contemporaries, it gave accurate positions that could not be ignored. Kepler's discoveries about planetary motion can be summarized in 3 laws, known today as Kepler's laws. Kepler's first law describes the path that a planet takes on its journey around the sun. That path is an ellipse. An ellipse can be thought of as a squashed circle. While a circle is a path located at a constant distance from a center point, an ellipse is a path that is made when the sum of the distances from 2 points is constant. Each of these points is called a focus. Kepler's first law states that a planet's orbit is an ellipse, with the sun situated at one focus of the ellipse. A number called the eccentricity is a measure of how much the ellipse differs from a perfect circle. Earth's orbit has an eccentricity of 0.0167. That means Earth's orbit is different from a perfect circle by only 1.67%, making it nearly indistinguishable from a circle. The orbit of Mars has an eccentricity of 9.3%, much more noticeable. Kepler's second law states that a planet moves faster when it is closer to the sun and slower when it is farther away. Knowing a planet's speed at any point in its orbit is essential in predicting where it will be along its elliptical path at a particular time. Kepler's third law relates how long a planet takes to orbit the sun to its average distance from the sun. It states that the square of the time for one orbit is proportional to the cube of the average distance. What this means is planets farther from the sun take much longer to orbit. For example, Jupiter is about 5 times farther from the sun than Earth, but takes nearly 12 Earth years for one orbit. Kepler's laws not only apply to planets, but to comets, asteroids, and even spacecraft. These 3 laws result from the interplay of gravitational forces and inertia, the resistance an object has to a change in its motion. While these physical principles were unknown to Kepler, Isaac Newton would soon bring them to light in his 3 laws of motion and his law of gravity. Newton was able to show that Kepler's laws are a natural consequence of his laws. Newton also realized that because planets gravitationally attract each other, their motion deviates slightly from an elliptical path. With Newton's corrections, Kepler's laws are still used to predict the positions of planets and describe the paths of spacecraft sent on voyages of discovery to reveal the secrets of the worlds in our solar system that the Greeks called wandering stars. Join us next time for another edition of Starlight Express.